See how to do chi-square test for independence for a given data using TI-Nspire CX. So our question is, a researcher wants to know whether there is a relation between the usage of seat belt with regard to gender. So as we can see on the right, this is the data. So you have gender, female and male, and the usage of seat belt. So yes, all the time, these are the responses. Most of the time, these are the responses, and not at all, these are the responses. So now the researcher wants to calculate, is there any way, whether the usage of seat belt is dependent or independent of the gender. Now, as we know, our chi-square test for independence, our null hypothesis, which is represented by H naught, it says that the usage of seat belt, it is not related to gender, meaning the usage of seat belt is independent of gender. And our alternate hypothesis says the usage of seat belt is related to the gender. Now to do this test using TI-Nspire, what we have to do is first we will click on menu, go to matrix, and we need to create a matrix. So I'll click on matrix. Now how many rows and column, it depends upon the data. So I have 2 rows and 3 columns. So 2 rows, it's fine, column is 3. Okay, now I'll enter my values 50, 32, 25, 43, 26, and this is 40. Now what I'll do, I'll name my matrix. That means I'll store it. So click on control, click on var, store. Now I'll name this matrix as observed matrix. Okay. Now to perform the chi-square test for independence, I'll click on menu, go to statistics, stat test, chi-square two-way test. My observed matrix, I'll click on that. So whatever you have named it, I've named it observed. So I'll select observed. Okay. And this is how your test comes out. So your p-value is 0.0392, which we are interested in. And clearly we can say that now it has been tested at a 5% significance level. So 0.0392 is less than 5. Therefore, we reject our null hypothesis. And there is an evidence to say that your usage of seat belt is dependent upon the gender. Now, the another way to do this is we can manually calculate our chi-square statistics value. That means this, which is 6.4784. We can do this manually and then using the degree of freedom. Now, remember in a contingency table, okay, or in a matrix form when the data is given, your degree of freedom is how many columns you have minus 1 multiply by the number of rows minus 1. So here I have 3 columns, so it will be 3 minus 1, which is 2, and I have 2 rows, so which will be 2 minus 1, which is 1. So my degree of freedom is 2 in this case. So I'll repeat it again. The degree of freedom in a matrix is number of rows minus 1 multiplied by number of columns, total number of columns minus 1. So in this case it is 3 minus 1 multiplied by 2 minus 1, which is 2 into 1. So the answer is 2. And we can also see the degree of freedom is 2 here. Now once we have done that, so once we have the degree of freedom and we have the chi-square calculated value, means what we have calculate, we can refer to a table and find out a critical value. And we can compare this with the critical value. So if our chi-square calculate is greater than the critical value, that means we can reject the null hypothesis and accept the alternate hypothesis and vice versa. So that we'll see in another video how to calculate manually your chi-square statistic, and and what can we compare, what can we say whether our null hypothesis can be accepted or rejected. So in case you have any doubts, please let me know. Till then, take care and have a good day.